We will begin at the beginning. The story of astronomy, the story of the universe which we inhabit, right from the word go. Those of you who attended my lecture a few days back would know that really the beginning starts with the time when hunter-gatherers slowly evolved into agricultural people, the agrarian revolution. But we will start at a much later point of time. Let us see the legacy. So, what people saw all around was the sky with some stars, some very bright objects like the sun and the moon. And the reason they looked up at the sky was, the moment they started agriculture, they needed a calendar. And that is why astronomy was born, because people realized that there was a correlation between the seasons and the movements taking place above. The rising of the sun, setting of the sun, again rising of the sun. This happens every 24 hours. The moon is now, let's say, a crescent moon. Then it slowly grows, becomes full moon, again slowly shrinks back to a crescent moon. This took place in a month. So from there we got the idea of the month. And then there was a more subtle change in the sky. Namely, if, for example, today at sunset, you saw a group of stars in the west, slowly that group of stars would disappear. But again, after 1 year exactly, the group of stars would appear at the same place, 1 year. That's the annual motion of the Earth. So you will be seeing all these aspects as you go on. But the point is, people took advantage of these periodicities to determine when to sow the seeds, when to reap the harvest, and so on, which is something we do even today, after so many thousands of years. Now, what we saw the other day was really a parallel branch of development of astronomy, which started with the Rig Veda, sometime around 10,000 BC. But then, history doesn't always go one way. It goes forwards and then comes backwards and so forth. So in fact, by the time we come to about 4 or 5,000 BC, already there had been some sort of a regression and people were starting over again. And this went on. The Egyptians, the Sumerians, the Babylonians, that is where today we have Iraq. So Iraq before the Muslim period. The Muslim period in Iraq started only around 600 AD. So this was long before 600 AD. Babylonia, Assyria, and all those countries. So they looked up at the sky and they started wondering. For example, they could think of the moon there, some stars there. And then they thought that the earth was like a flat pancake which was floating on some sort of a liquid. And all these objects went round the earth. That is why people explain, we see the sun rise, go up, set, moon rise, go up, set, because they are all on this sphere, and the sphere rotates around the earth, which is in the middle. This was the earth with the mountains. This was, in a sense, the first crude model of the universe. But they had to go one step further. They had to observe the sky to map out the months, the years, and so forth. So they divided the sky into 12 parts because they noticed that it would be convenient to break up the 1 year into 12 one-month periods each. And then they dreamt of several star patterns in these 12 parts, which we use even today, the zodiac constellations, and the earth itself in the middle. So this was a slight improvement. And this was the case already by the time of the Babylonians, around 500 BC to 1000 BC. But even this was not enough. Why it was not enough, you can well guess. If every object rose in the east and set in the west and rose again in the east and nothing else happened, then that was okay. But we know that the sun moves through the stars. The moon moves as it goes through its phases. The moon is going around the earth. So the various other objects are also moving independently of the stars. So they had to think of something better. And here is what they thought. The earth is at the center. Initially, they kept the earth at the center, and it was surrounded by spheres. Now spheres, because in 500, around 500 BC, 550 BC, Plato, the great Greek philosopher, he taught that the universe is perfect, whatever that means. And in a perfect universe, there has to be perfection. And the circle and the sphere were perfect objects because of their all-round symmetry. So, the idea then grew that with the earth at the center, the various objects were attached to spheres going around the earth, different spheres. Now, these spheres were not imaginary, they were actually material, transparent spheres to which these objects were attached. Otherwise, the objects would fall down. I mean, that was common sense. Everyone saw, not just Newton, that anything falls down from the top to the bottom, if it's unsupported, of course. So it had to be supported. And they kept various objects on various spheres. The object that moved or appeared to move fastest, namely the moon, they attached to the first sphere, and then so on it went. Planets, sun, all these spheres had independent movements, and that is why they argued the sun, the moon, etc. have different motions compared to the stars. But even this was very crude because it explained things to a certain extent, but only to a small extent. If we actually look up at the sky, we find that the planets sometimes move in one direction, then they stop and start moving in the opposite direction, what is called retrograde motion. So how do we explain that? If there were independent spheres going around independently, that wouldn't be explained. So people like Anaximenes, around 500 BC, they came forward with a little more of an ingenious explanation. They said, look, these objects were attached not to the main sphere, but to the sphere which was secondary and had its center on the main sphere. So the objects would have a double motion of the main sphere which went round carrying the center of the secondary sphere, and then motion around the center of the secondary sphere. So by this combined motion, they thought everything would be explained. Actually no, because there were other factors also. Sometimes a planet appears brighter, sometimes it appears not so bright. There was a variation in brightness. So then came the idea that, of course, that's because the Earth is not exactly at the center, but it is a little away from the center. So when a sphere came close to the Earth, the object would appear bright. But it went far away from the Earth, it would appear fainter. And then came the further degree of complication. The center of the initial sphere itself would be going around. So it became more and more complicated. In effect, what all this meant was that a planet would go around the Earth like that, not in a smooth circle, but in this sort of a circle, sometimes going in one direction, sometimes opposite direction. This was the main result, but not this simple curve. This was effectively this. Basically, they were on spheres and the spheres were rotating. Next. Well, then around 250 BC, a very important experiment was performed by Eratosthenes, who was the librarian of the great library of Alexandria. What he noticed was that the length of the shadow of sticks placed vertically kept changing from day to day. In fact, we know it. This is one measure of what is called the nonum, or a clock. Most elementary type of clock, sundial clock. But he went one step further and argued out a theory. He said, look, the sun's rays are coming from a great distance. Now consider a stick on the earth. If it is vertical, it would be in this direction, because the vertical is the direction joining the center to that point on the earth. So that would be the stick along this line, radial line, and the rays of the sun are coming vertically, therefore you would have a shadow. This was the brilliant explanation of Eratosthenes, but he went one step further. He measured with the help of an accomplice the length of the shadow at two different places. One was Alexandria and the other was a place called Syene. And they measured the shadow. In one place it was practically zero, in another place it was not. So Eratosthenes, knowing the distance between the two places, could say, knowing the angle of the shadow, using simple trigonometry, he could measure the circumference of the earth. And he came pretty close to the correct value. In modern units, he did use something like, he was using a unit called stadium, the same stadium we use today from the Greek Olympics. So, in these units, he got something like 25,000 miles in today's units. That was a great piece of observation. The earth was round and he measured its circumference. Two birds at one shot. So the idea was somehow to keep the Earth at the center, surrounded with so many spheres with various planets attached. The fastest moving would be the Moon, first sphere. Next fastest, Mercury, next sphere, and so on it would go. And finally, the stars in the last sphere. Well, this model lasted for nearly 2000 years. It lasted till 1500 AD, nothing much happened. They were just tinkering. The Greeks were tinkering a bit, a little here, a little there. But basically it was the same. Earth at the center, so many spheres, one sphere on another, another sphere on that, and so on. And then one of the spheres would go itself in a circle round some other center. A great degree of complication. Nicholas Copernicus, around the early 16th century, he somehow thought, look, why not we change the position, interchange the Earth and the Sun. The Sun at the center, the Earth going round the Sun. Maybe things would become less complicated. Copernicus tried this, but things really didn't become less complicated.